All right, let's get started. Let's do this. So last time, and I'm going to double check, even though I just did this. Last time, I was not intentionally ignoring chat. I just want to put that out there. I kind of messed up. My phone, by default, connects to UB Connect, which doesn't do anything. I don't know why it exists. Probably some reason. Instead of EDU Roam, so now I'm on the right Wi-Fi network. I can see your messages. I have a lecture right before this, and that lecture and this lecture on Monday, I'm like, how did I go through 2 lectures with nobody using chat at all? So I checked my Wi-Fi, and it was the wrong one. So I got the right one now. I did not do that intentionally. I don't ignore chat. I was very sad. I'm like, why is nobody asking questions? It was my fault. I blame UB, and I blame Paul. I think Paul set up my phone to connect to the wrong Wi-Fi, honestly. But all right, so let's do this. We got to the last slide. This is the last slide from yesterday's stuff. We got to this slide, but I just really rushed it right at the end. I'm like, hey, by the way, there's these testing tips. So I want to give these a little bit more justice. We have 3 different ways of testing, I guess, that we saw, or that I want to talk about. The first one is assert true. This is the one that we saw all throughout Monday's lectures, is assert true. You give it a Boolean statement. If that Boolean statement resolves to true, the test passes. The test case passes. If it resolves to false, the test case fails. This is our basic tool. This does anything you would ever want to do with testing. You can do with assert true, but it's not always the most convenient thing to use. So we have assert equals, which takes 2 parameters and checks if those 2 values are equal to each other. This is often, if you actually do want to check 2 values for equality and it works with the assert equals method, this is usually the better one to use because, it's a little more descriptive of what you're doing. But 2, it'll give you better feedback if the test fails. So if your assert true in the first example passes, it says passes. If it fails, it says fails. It doesn't tell you anything else. Assert equals, if you use this and your test passes, it says passes. And if it fails, it said your test failed. I was expecting to see, oh man, I always forget the order here. I might have the order backwards. I was expecting to see 5, but you gave me whatever the value of result is. And it'll tell you expected it versus actual, what the comparison actually found. So it gives you more information when your tests fail, which is much appreciated when we're debugging. We want to know why the test case failed, not just that it failed. And we can take that to another level. We can add hint strings by giving a first parameter, which is a string, or argument, I guess, on this side. A first argument that's a string. And if you give assert equals, assert true, or any other asserts, there's all kinds of them. Assert false, assert null, assert not null. There's all kinds of them you're welcome to use if you want. These are the only 2 I'll need to talk about in lecture. Because this will do, just assert true will do everything you want. But the other ones can be handy. But this string, any of these, assert true, assert equals, if you give an extra argument, the first one being a string, and then whatever else you would normally give it, this string will be printed to the screen if your test case fails. So if you want extra information about your test case when it fails, because if it passes, we don't need to know anything. Everything went well. Great. I don't need any more information than that. But if it fails, I want to know why it failed, get more information, so I can debug, so I can find that bug and fix the bug. So that's what we want to do with that. So, all that, I was working on the order for so long. Oh, no, I did get the order right. I just forgot. So to that end, let's get into today's content. How can a string be in there if the type is int? So in this example, you're saying assert that result equals 5. So it's still checking if these 2 values equal each other. That's what the assert equals is going to do. And if they equal each other, that's it. That's all it does. It does the same thing as the example in the middle. But if result is not equal to 5, again, that's the only comparison it's doing. If result is not equal to 5, it'll look at this string and print this string to the screen, which will show us what result actually was. It'll say, give some extra information. Now, in this example, this is the same information that assert equals is going to give us if it fails. So we don't actually gain much in this example. But the point is that you can add a string to print out whatever you want. Result, maybe you want to print out what the input was. I want to print out 0. Oh, we do print it out. So it is extra information. The input was 0. Any extra information that can help us debug. When we're just adding 5, there's not much I can throw in this hint string. But when the testing gets more complicated, we might want these hint strings to be able to give us more information about what exactly failed. Why exactly did this thing fail? So the string's not part of the comparison at all, is what I mean by all that. It's nice having chat again. Does assert equal use reference or value for objects? It will use value. So specifically, it'll call the equals method for those objects. So if that object does not have an equals method overridden, then it will default to the default equals method, which is reference. So if you're calling assert equals on objects that you created, then, I almost referenced task 2. Task 2 is not released yet. But you'll create like a song object, a song class, and then song objects. If you call assert equals on song objects, it'll compare them by reference. So it won't do what you want it to do, because it won't have an equals method. But something like a string that is actually the next thing we'll see does have an equals method, and it will call the equals method, not the equal operator. That'll make more sense in a second, because that's the next thing I want to talk about. I went to these slides just to get to this slide that says demo, because I'm going to do a demo. So let's take a look at this example we had last time. I have this beautiful method that adds 5. We can just verify that it's correct. Why do we need unit testing for this one? But let's take a look at our unit tests. When we run this is what we're going to see in IntelliJ. I have all the tests that we saw in the slides. And this is the examples repo, week 3, if you want to find this code. These are all the tests. And if we want to run them, we're going to see all kinds of go buttons in what we call the gutter over here. All kinds of go buttons. I don't like using these. What I like to do is right-click on the test, or on the file itself, and go to run. And it's going to run my tests and show me the results of these. When you see green check marks all the way down like this means the code passed all of these tests. And these tests are pretty comprehensive, so we're feeling pretty good. We could still have a bug in here, but we're feeling pretty good that this one passes. The reason I don't like using these buttons here is I might click the wrong one. This button is associated with just the test add 5 method. So if I run that one, I'm only running this method, and my other methods are not being executed. You would have to hit the one associated with the class. And just to make sure I don't misclick, I just go over to the file and make sure I get everything. So just an explanation why I don't like the buttons in the gutter. Because I've hit the wrong button before and said, I'm passing my test, what the hell? It's because I was only running one test. You only do that one time before you never do that again. And then if I go back to my code and break the method, now I have an incorrect solution. This is wrong. Code is wrong. I'm going to go back to my tests. I'm going to run it. Now I get to use this button because add test is the last thing I ran. So I can use this handy button. And when your tests fail, you're going to get this X. You're going to click on your test. This test add 5 failed. And it tells me just about nothing because I used assert true. It does tell me which line failed. So if I click on this blue text, in general, whenever you get errors like this, you can click on the blue text to jump right to the line that caused the issue. And it will tell me which test case failed. So I know this one failed, but I don't get any information beyond that. I just get, hey, this failed. And once one test case fails, the first test case here failed, it stops running your test method. The test just shuts down right there. So the next tests in this test method, the other test cases, never get executed. My next test with negatives, same thing. I used assert true. I don't get any information, but I do get the test that failed. So that is some information, but I don't get to see what add 5 actually returned. I know it didn't return 4, but that's all I know is what it returned was an int that was not 4. It doesn't really narrow it down too much. My edge case test, same thing. Don't get any information. But when I use assert equals, now I get some extra information. With the assert equals test, when I say assert equals, I have it backwards in my slides. I fixed it in the code, but didn't update the slides. The first value the first argument should be what you expect, and the second one should be what you actually got from the method, the value that you're testing. And when it was correct with the green check mark, it didn't tell us anything. I didn't click on it, but it wouldn't tell us anything. But when it's wrong, when it fails, it gives us this nice display. I expected 5 because that was the first argument, but you actually gave me 6. Now I have more information. I'm off by 1. I can go in and fix my bug. Obviously, we know what the bug is. Yes, we're adding 6 instead of adding 5. But this can be very helpful when you're debugging more complex methods to tell you what exactly is going wrong. And then with the hint text, this one with the hint text, we're using assert equals, so we still get the expected and actual, but then we also get our hint text. Expected 5 on input 0, but got colon, and then whatever result was, and we can see that result was 6 on input 0 instead of 5. So we can be as descriptive as we want to help us find that bug. Why did this test case fail? Well, on input 0, it's supposed to get 5, but it actually gave 6. Okay, now we can go start debugging. Why did we get 6 instead of 5? And of course, it's because we have 6 here. Change that back to a 5, rerun our tests. And if I click through all these tests, I get nothing. Doesn't tell me anything. The test passed. What else do I need to know? Don't need to know anything else. They passed. I'm happy when they pass. Okay, next I have this wonderful method, combine strings. Just a smidge more complex than adding 5. Yes, I know. It's a really basic, simple method. I want to talk about testing. That's why these methods are simple for now. It takes 2 strings and returns them concatenated together, separated by a space. I think I wrote this correctly. Concatenates the strings, puts a space in between them. Cool. I'm going to write a test for this. My first test, I have 2 strings that I want to concatenate. I'm going to call my combined strings method, and I expect this to be equal to those strings concatenated, separated by a space. Hello, goodbye, or hello, space, goodbye, more specifically. That's what this method should return. I'm going to do this with assert true. I'm going to do this with assert true, but in a slightly different way. I'm going to use dot equals instead of equal equal to compare these 2 strings. So every object in Java has an equals method. We kind of got off on a little tangent earlier, and now we're wrapping that back to, back to the actual content. Is assert equals will call this equals method that exists for every object. So the next example, I'm going to use assert equals and give it those 2 strings. And what assert equals is going to do, I think it's time we can start going into Java stuff. I'm doing command click or control click on Windows on the method. That's going to take me to its definition. Assert equals calls another assert equals. Java code gets kind of messy, but if we get in here, eventually we're going to get to a method and see that it is just calling dot equals on these objects. It has some extra stuff. It was doing some handling of nulls and other stuff. But deep down under the hood, it's just calling dot equals. That's what assert equals is fundamentally doing. So these 2 tests are effectively the same, the dot equals and the assert equals, except assert equals is going to give us more feedback. So let's run these tests. I can't use my go button up here because that's going to run the add test. I want to run the string test. So I'm going to right-click and run. And 2 of those passed. This one failed. Oh, I don't know about that. Let's come back to that one. I have another method I want to test, about as complex as adding 5. I'm going to multiply 3. This time I'm using doubles instead of ints, and I'm going to multiply 3. Very complex method. Yeah, I know. I'm a programming god. I wrote this thing that times 3. I'm great. This is a hard method to write. It took me a while. So let's test this thing. First, I'm going to call this method on 0.1. If I have 0.1 and we multiply that by 3, I'm going to expect the output to be 0.3. I'm going to print out what we get and then assert true that what I got was, in fact, 0.3. I'm going to do another test where I'm going to use this compared doubles thing, this method. We'll talk about that when we get to the slides, what exactly I'm doing there. And then finally, I'm going to call assert equals, but I'm going to give it 3 values. Again, we'll talk about that in more detail when we get to the slides. But 3 different ways that I'm comparing these 2 doubles. So let's run these. We expect all these to pass because, obviously 0.1 times 3 is going to be 0.3. And, oh, crap. Well, 2 of them passed. This one didn't pass again. We're not doing so good on these things. So this one didn't pass. And furthermore, when I'm printing out y, I can see that it's not quite 0.3. It's just a little bit different than 0.3. To us humans, that's effectively 0.3. Like, who cares about that trailing 4 way over there? The computer cares. That is not 0.3. It's not equal to 0.3. So let's talk about all this stuff. So we had 2 tests in there that naturally we would expect to pass that actually failed. Let's talk about it. Let's see why they failed. Why unit tested is better than print to the result to the council. Treat as interview question. So I have to be a student. Okay. So if we print to a TA just asked me this. So when we print to the council, we have to manually look at that. We have to go in our IntelliJ and see the values and then verify that those were the right values. But with unit testing, all I have to do is hit that green button in IntelliJ, and it just tells me if all my tests pass or not. I don't have to look at anything unless my tests fail. I might want to check it out. But I can just hit one button instead of looking at all the output for all my testing. Did I pass? Then I have to bug the TA and everything. Yesterday, the TA told me to use a third argument of 0.000001. Should we only do this when we have doubles? Yes, it's only when you have doubles. And the exact value is up for a little bit of debate. I'll use 0.001 in my slides. That's going to be fine for your homework. That value that the TA said, that's also going to be fine for your homework. So the exact value, it's not too particular, but when we get to that part, we'll talk about it. So testing strings. We had a string test that looked very straightforward, very simple, and it failed. Let's talk about why. So this test fails. All we did was concatenate technically 3 strings and checked if the output was equal to what we expect, and it failed. And the TLDR of this one is never use equal to compare your strings. Small asterisk, but in Java. In Java, never use equal to compare your strings. In pretty much any other language, equal is going to do just fine. Maybe not C++, but don't use equal to compare your Java strings. So all this semester, no equal to compare your Java strings. Ever, never, ever. Whether it's in a test case like this, or if it's in an if statement. If you have a conditional and you're saying if these 2 strings are equal to each other and you're using equal, you got yourself a bug in your code. Things aren't going to work the way you expect it to sometimes. Sometimes this actually works. Sometimes you use equal with strings and it'll work fine. Sometimes it won't. Do you want your code to sometimes work or do you want it to always work? Hopefully you want it to always work. Don't use equal to check your strings for equality. And the short answer to that is why. Strings can be pretty weird in Java. The little bit longer answer, without getting too lost in the details, is strings in Java are immutable. It does start with a capital S, which tells us, strings all over this slide. I can't find one to point to. Right there. It does start with a capital S. That means it is a class that defines the string type. It is not a primitive like I, lowercase d, double, lowercase b, boolean. It's not a primitive, which is just a value. Since string is a capital S, that makes it a class type. And then strings are actually objects which are stored on the heap and referenced by references. When a variable stores a string, it actually stores a reference to that string. Now, in our memory diagrams, we pretend that strings are stored by value, but they are actually stored by reference, and this is the one time where we have to care about that in 116. This is the one time we have to care that strings are actually referenced. So when we use equal on variables that store references, we're comparing, is this string the same exact string as that string in memory. Is this the same memory location for these strings? And the way I set up this test case, but fairly carefully actually, to make sure we expose the bug, is that these two strings are going to be two separate objects on the heap with two different references, and equal is going to say, no, these aren't the same because we're not referring to the same object. So that doesn't work. If we use dot equals instead, dot equals will call the equals method of the string class, which will compare the values. It'll go character by character, check if it has all the same characters in the same order and the same length, and then say, yep, these two string values are equal, not the references. So that's the difference between equal and dot equals. Dot equals is going to check the values. If there's an equals method overridden for that, the default equals method will compare by reference. So this isn't always our solution, but for built-in Java types, this is often going to be our answer. String has an overridden equals, which will compare the characters. That's what we want in this case. So this test passes as it should, and we're feeling good about that. And usually, it's just easier to use assert equals. If you want to remember to do dot equals all the time, just whenever you're comparing strings, if you don't remember all the references and immutability, I didn't really explain immutability. Immutability means the value of a string can never change when it's on the heap. So oftentimes when you set a variable equal to the same exact string as another variable, they'll often share that reference and refer to the same object. So if you have the same string many, many times in your code, in your program, it'll often just be created one time in memory, and all the variables will refer to that same string. And since that value can't change, they don't have to worry about one of those variables changing the string and then all the other variables referring to the wrong value at that point. So Java is pretty sophisticated in the way that it saves memory by reusing strings and making them immutable. So that's why sometimes the equal will do the right thing. It's just up to Java whether it's happened to be saving memory at that point or not. Since I concatenated strings inside a method call in a separate stack frame, it didn't end up sharing that memory address. So I did get two separate string objects with the same exact value. So let's stop that tangent, though. I don't want to keep going down that one. The short answer is don't use equal to compare your strings. You can use dot equals. If you're in a conditional and you want to check, are these two strings equal, use dot equals. If you're in test case, the world of JUnit test cases and unit testing, you can use this assert equals. It'll do the same thing, but it'll give you that nice hint text if your test fails. So it's just a little more convenient to use. But you could use assert true, and dot equals is fine. If your code's right, then the difference between assert equals and assert true with dot equals is the same thing, because they're both not going to tell you anything if it passes. Okay, before we get into that one, any questions at this point? 3:23, yeah, we got time. Yep.
Is there any reason?
Yes. So is there any scenario where you should use assert true over assert equals? So you're not always comparing two values for equality. So whenever that's the case, you want to go to assert true. I thought I had an example off the top of my head, but I didn't have one. There is a task that will come up. Like everyone who gets stuck in the habit of only using assert equals all the time, which is fine as long as you remember assert true exists. There is a task where we're just not comparing two things for equality that we'll want assert true. I'm not coming up with it. But it does come up. In this course, it will. Yeah, it can't come up with it. Right from task one. When you want to check, did this method output either cat or dog? You're not going to be able to use assert equals for that one. You have to use assert true and build your actual Boolean expression to check for either output. That one you're not going to use assert true for, or assert equals for. Can you use assert equals if there's two possible correct outputs? Okay, yeah, I obviously you typed that before I said what I just said. But Not to my knowledge. There might be a method. I don't think there is, but there might be a method somewhere in the library other than assert equals that takes like an array list of possible answers. I don't think there is, though. Just use your or statement. Okay, let's revisit this code. So last time we saw this code, we saw the letter method. Now we're going to see the other half of this, the plus minus, to be able to compute whether the grade should be a plus, minus, or no modifier associated with it. This is, I'll be very upfront with this, this is directly showing you how to do the sum of digits method. We're going to use the modulo operator here. We're talking about testing, but I want to talk about the code a little bit. We're using the modulo operator, which I have to assume you've seen in 115. If not, it's going to be the remainder after division, only the remainder. So you're getting just the quotient and just the remainder and doing integer division both times. So we're going to take the score and modulo, divide it by 10 and take just the remainder, so modulo 10. That's going to give us a value from 0 to 9, which is exactly the ones digit. If I'm computing the sum of digits and I use modulo 10 to grab the ones digit, add that to my running total in my accumulator, and then divide by 10, that's going to shift everything over by 1 and erase that ones digit. And I do modulo 10, get the new ones digit, add that to my accumulator, divide by 10, modulo 10, divide by 10, modulo 10, divide by 10, modulo 10. Just keep doing that until I run out of number, until I've processed the whole number. I think that's enough. I won't walk through the entire code, but from there you can definitely figure it out. So this example is specifically designed to help you with that. It wasn't always clear, and then students are like, you never showed us how to do this sum of digits crap. What the hell? And students are trying to convert it to a string and then do all kinds of crazy stuff. I had somebody convert it to a string, then use the ASCII characters for the ASCII encoding for each character, subtract the whatever 0 is in ASCII, and then add those up, which, hey, it works fine, but it's way more complex than what I intended. But it worked. I mean, it works. Anyway, so we want to test this thing, and the behavior that we want from this plus minus is that if the ones digit is 7 or more, plus, less than 2 or less, minus, and then everything else is no modifier. That's what we want. And we have a few test cases. 95 should have no modifier. 78 plus, 51 minus. And we're going to write this as a unit test case. We had it as a main method here. Let's rewrite that as unit testing because that's what we want. And I'm going to use my hint text and assert equals here to get the full thing. The big thing that the hint text is giving me is what the input was, because assert equals isn't going to tell you what the input was. It has no way of knowing what the input was. So we're going to get the input in our hint string. So assert equals, I don't have to read that. We've been talking about testing for a while. So we're going to use assert equals and hint strings. And it passes. Yay, go us. Not pulling any punches on this one. We passed all 3 of these tests. We're using assert equals, so we're not comparing strings with equal. Everything's fine. And then we're going to sit down and look at our testing. Like, we had 3 test cases. If you submit with 3 test cases to Autolab, like especially for this one, Autolab's going to say, you got a lot more testing to do. So, and we're not going to build this out all the way. I think we scrapped that lecture. But we used to, later on in the semester, revisit this and add, we'll have like 25 test cases. We hit all of the all the boundaries and all kinds of stuff. We're not going to do all that, definitely not today. But let's at least think of our edge cases. Right? There's one big edge case I can think of. That's 100. Student gets a perfect score in this course, this fictitious course. Obviously, we don't have percentage-based grading in 116. But 100, that student should be getting an A+. And they don't. They're of course not going to, if you look at the code, of course they're not going to get their A+. They get an A-. And this is where we, and certainly this student, are going to demand perfection. We have to pass every single test case. If we have a bug somewhere in our code and everybody with 100 in our course gets an A-, it's a pretty damn big bug. Yeah, it's one single test case. We're right from 0 to 99 And we don't handle anything outside of 0 and 99, so we'd have to 0 and 100, so we'd have to have some extra code here to handle those situations. But like 101 would get an A minus. Yeah, 101 would get an A minus as well. So we have a few other bugs if we want to think of the outside the realm of possible grades. If we have extra credit or negative grades, extra stuff we got to handle. But in general, from 0 to 100, we have one bug at one value. And technically, we have F minuses and F pluses, which when I do the whole lecture with tons of test cases, we fix that one too. But that's a big bug. This is a big bug. One test case. Technically, we got 99%, right? If we're right 99 out of 100 times, it's not good enough. We demand perfection in our software. Our software has to be right. It has to be correct on every input, or else we got ourselves a bug. So we got to fix this. But what we're doing here is, on my next slide. The goal of writing tests is we're trying to expose these bugs. When you write tests, don't do what a lot of students do. A lot of you will still do it, I know, but I have to at least say it so I can say I said it. But don't just write a couple of test cases and kind of half-ass it. I'm going to write 2 or 3 test cases, submit to AutoLab, and see if that's enough. What I really would love to see you all do, because when test cases are not required, this is what I would like you to have this habit, and it's hard to force you all to do this, is just sit down and write good tests. Sit down and think of any bug that could possibly be in this code. For this code, there's lots of bugs that could be. Our edge case of 100, we can expose the bugs of F minus and F plus if we have some test cases for those. We can check every edge of every boundary. So I want to make sure that an 89 is a B plus and a 90 is an A minus. So I'll have test cases for both those to check that boundary. Make sure it switches from B plus to A minus at the exact right integer value. There's lots of tests, lots of bugs we could have here. If I mistype one integer somewhere in this code, a lot of bugs we can have. So let's write test cases for all those. Just sit down and write a really nice, thorough test suite by thinking of any bugs that could happen after you come up with your common and uncommon cases and just a bunch of test cases. Come up with all those potential bugs. Where could somebody have written a bug? 0 would be another one I'd want tested specifically. It's that student who never showed up ever all semester and didn't do a single thing, which there are always, in this class, in this section right now even, there will be students who don't do a single thing. Never show up to any lecture, don't submit anything, never even a single lecture question, nothing at all. I want to make sure that student gets an F. They need to get an F, right? So I want to make sure I test that case as well. If I have something that wraps around and they end up getting an A or something, the rest of you all who actually did their work are going to be pissed. They shouldn't get a passing grade. Anyway, we're going to think of the possible bugs and then write test cases for those bugs. And expose the bug. This is our debug cycle. Write test cases, run the test cases, expose any bugs, fix those bugs, run our test cases again, keep going through that cycle until we're passing all our tests, and then it's time to submit to AutoLab, and hopefully AutoLab says, yep, you're good. If you have a really good test suite and you're passing all your tests, and you sat down and thought about all the possible bugs, wrote test cases for all of them, AutoLab's most likely just going to say, yep, you're good, unless there's some strange compatibility thing. Maybe you misspelled one of your method names or something like that, can happen. But once you fix those little things, you're going to be good. Often. Not always. Often, though. Sometimes AutoLab will test something that you didn't think of, and you got to go back to the drawing board. Not back to the drawing board, but add a few more tests. Okay. Testing doubles. Any questions on this? I see some in chat, so let's talk about this. Expose the bug, tally count 15. Oh, how many times I've said it? Oh, my goodness. I did 312 right before this and right after this, actually. It's the lecture on cookies. I got to say cookies 80 times in that lecture. Expose the bug, expose the bug, expose the bug. When will test 2 be released? Soonish. At the very latest, Monday. So when the content for a task starts, that's my deadline for myself. I'll always hit that one. So Monday morning by noon, because that's the first 116 section, the first of Paul's sections, it will absolutely 100% be released by then, or else you know that I'm somewhere stressing over it, trying to get the thing released immediately. More realistically, my plan is tomorrow, get it released tomorrow. How do you go about doing test case? And there's a little bit of redesign. I'm restructuring the output and a little bit of the structure of the test. So once test 2 is released, it's going to open up the floodgates so I can revise 3 through 8. They should all come out fairly quickly after 2 is released, once I have the new structure. How do you go about doing test cases if you have a system that has lots of classes with properties that are also custom classes and so on and so on? Initializing all those classes would be painful, or it modifies the state of the system outside the method. Yeah, you just do the painful way. You create objects of those types, call the methods, and make sure all the methods are returning the same thing. So the very first thing you'll test is creating an object, calling the getters, making sure all the getters return what they're supposed to, then start calling the setters, and then call the getters again to make sure the getters return the new updated values. Then call any other methods that change the state, and then call the getters again, make sure the state changed properly. Yeah, it's just kind of tedious. It's a little tedious. Not too bad, though. It's not that bad. Okay, we better talk about testing doubles. Actually, we're not too much of a time crunch right now. In plus-minus method, you have used equal equal. I used equal equal for ints. So int is a primitive value. Since it is just values, equal equal will compare the values. Like the variable score legitimately just stores the number for that int. So I can safely do equal equal on these primitive values, except doubles, because it will actually compare the values, whereas with strings, it's an array list and hash map for what it's worth. Those are all object types that are references to objects on the heap, so those will be compared by reference. But ints, I can use equal equal. Ints and booleans, really the only ones we'll see this semester that we can safely compare with equal equal. For best key method, do we do assert true with spoilers? Or be careful posting potential solutions in chat or anywhere publicly. This one's fine because I talked about it in lecture. Do we use assert true with or can we assert equals with or? Do assert true with the double pipe, with the or operator. Which is basically my hint, because I get sick of having that one in office hours every semester, so I'm just spoiling that one in lecture. Because it's not, I always took it for granted that that's going to transfer over from 115 and I don't have to talk about it, but the syntax is different. The double pipe instead of the actual literal English word or, so I got to talk about it a little bit. Or not in all life. That one better pass. So this test also fails. We use equal equal with doubles. We don't use equal equal with doubles. Problem is 0.1 times 3.0 is not 0.3. And this is true in like any language. You can do this in Python, JavaScript's weird. I think JavaScript gives you 0.3. But most languages are going to not give you 0.3 exactly when you do this multiplication. So why is that? It's because they're all representing doubles the same way. Doubles use a 64-bit bit representation. That's exactly this. 1 bit for the sign, plus or minus, whether 0 or 1. And an 11-bit exponent and a 52-bit fraction. And this is effectively binary scientific notation. So we have the fraction point, so we have 1 point, and then whatever the fraction is, raised to the exponent, and then plus minus with the sign. That's the very brief explanation of how this is stored. 220 is going to go into more depth on this. It'll show this structure again, and you'll have to think a bit more about how this works. For our purposes, what we need to know is that 64 is a finite number. It is not infinity. That's all we really need to know. I'll give explanation of why that matters right here. if we think about binary, and I do assume that you've all seen binary before at some point, probably in 191. It's got to be one of the first things they cover in 191. If not, it's ones and zeros. If not, you can get away without understanding the slide. I just want to give the background of why we handle doubles the way we do. So decimals and binary, I assume you know binary itself, but decimals and binary you probably haven't seen. So let me explain that one. Decimals and binary, 0.11 here. What we do is treat the first value after the decimal as the 1/2 place, then the 1/4 place, 1/8 place, 1/16 place. Just like in decimal, we have the 1/10 place, the 1/100th place, the 1/1000th place, etc. It's 1 over the base to an increasing power. So 1 over 2, 1 over 2 squared, 1 over 2 cubed, 1 over 10, 1 over 10 squared, 1 over 10 cubed. So that's how our decimals are working. Just the base is different. We have a base 2 instead of a base 10 system here. Same exact thing. With base 10, there are certain values that we cannot represent with a finite number of digits. 1/3, we can do 0.33 and write 3s until we're sick of writing 3s. It will never, ever, ever, ever be equal to 1/3. It's not exact. And we learned this in high school and stuff. It's not exact. Same thing is true with 2s. And 0.1 happens to be one of those numbers. So 1/10 in base 10 cannot be represented exactly in binary, including many other numbers. 0.1 is just the one I chose for the example. 0.1 in base 2 is 0.1 in base 10, so 1/10 is equal to, in base 2, 0.000110011 and 0011 repeating forever out to infinity. So with a 64-bit representation, eventually we have to stop writing down 0011 and cut it off when we run out of 52 bits for the mantissa. We got to stop writing that down. So 64 bits can't store an infinitely repeating decimal, so we have to truncate. So 0.1 in a machine using this 64-bit double representation that's standardized by IEEE for what it's worth, this representation cannot represent 0.1 exactly. It will be just a little bit off. So when we multiply 0.1, and 0.1, it still print as 0.1, but once you start doing math with it, that truncation error is going to compound, and you're going to start seeing it. It's going to start having an effect on your code. So the solution to this is never to use equal when comparing doubles. We're never, ever, ever going to use equal when comparing doubles. If I catch you using equal to compare doubles, at least in Java, I'm going to, I'll just cry, I guess. Be like, they didn't learn their lesson. What the hell? Why did I pass them? Within this semester, that's just a teaching moment. But after this semester, I'll just be like, man, I didn't get the point across. God damn. Wait till Pi hears about this. Yeah, pi cannot be represented in a computer. Like, we can't have an exact representation of pi, at least in a single value. We just can't. But, we can't do it in the real world either, for what it's worth. Being irrational. So what our solution to this is to never check doubles for equality. We're just going to check doubles to see if they're close enough. If two doubles are close enough to each other, we're going to call them effectively equal. So I wrote this method, this compare doubles method, which is going to compare two doubles, but allow for some error between the two. So what I'm doing here is creating a variable, and again, sticking with my theme, I'm going to throw some fancy stuff at you because it's a second computer science course. I'm going to start throwing some extra stuff. This could just be hard-coded 0.001 right here. That would still work the same way. I want to show you constants in Java. So I'm using the final, private final double. So double is the type of the variable epsilon. That we know. Final means this is a constant. We cannot change the value of this variable ever. Whenever we have constants in Java, it's custom to put them in all capital letters. So all capital epsilon is a proper name for this thing. And private, this is our first private variable, which means this variable can only be accessed from code inside this class. We can't access this from anywhere else. So we have this variable that's going to help us write just this class and set it equal to some small value. The value of epsilon can change based on your application, whatever you're writing. For this course, if you just use 0.001 all the time, I'm pretty sure that gets you through everything, unless I'm forgetting something, but I believe that gets you through the whole course these days. That wasn't always true. Anyway, but we make sure that epsilon is large enough to allow for truncation errors, and you saw how far out that 4 was on the 0.3. Like, truncation errors are tiny, but it needs to be large enough to allow for truncation errors, but not too big that it's messing up the logic of our code. For example, if we had an epsilon of 10, well, now we're allowing something to be off by up to 10 and still calling those doubles equal. We don't want that in our code. So 0.001 usually serves me pretty well. And then we want to make sure we take the absolute value of the difference and make sure the absolute value of the difference between the two numbers is less than this epsilon. And epsilon, I stole that from math. Whenever there's a small value in math, they call it epsilon. So I'm like, I'll call this epsilon. Take the absolute value. Make sure you don't forget this absolute value. For example, if you have 5 and 10 million, 1 million, and you're comparing those, the difference might be negative roughly a million, which is less than 0.001. Make sure you take the absolute value of the difference and then make sure that's less than epsilon. Don't take just the difference. It's a common bug I see in office hours every semester. Somebody forgets their absolute value and things break. Or just use assert equals. If you don't want to mess around with any of that and set up your helper method like that, just use assert equals. When you give assert equals 2 doubles, if you just give it 2 doubles, it's going to yell at you. It's going to say, what are you doing asking me to, or I said assert equals, right? What are you doing trying to get me to check if 2 doubles are equal to each other? That's not going to work well for you. It's going to take a third double, and that's effectively going to be your epsilon on the previous slide. That's going to say, are y and 0.3 within 0.001 of each other, where we call 0.001 the tolerance in the JUnit library. That's the tolerance. As long as they're within 0.001 or whatever you give it as a third argument of each other, this test case will pass. And if they're further than that apart, this test case is going to fail. So that's how we use check doubles for effective equality. We never, ever, ever use equal to compare 2 doubles in Java, at least, in most languages. Why is there no test? Oh, I forgot to mention that. Oh, I want to talk about that. So the test annotation says run this as a unit test. This is a helper method that's going to support our test, but it is not itself a test. So I just don't put the test annotation here. So the test annotation doesn't just automatically go in every single method in your tests. If you have helper methods like this, just don't label them as tests, but I am calling them from my actual tests to help write those methods. And you can have assert true and assert equals inside your helper methods. My music didn't start. Man, it's frustrating when it